Sine theta is equal to 1 over cosecant theta. Cosine theta is equal to 1 over secant theta. Tangent theta is equal to 1 over cotan theta. And then cosecant theta is equal to 1 over sine theta. Secant theta is equal to 1 over cosine theta. And cotangent theta is equal to 1 over tangent theta. Let's do an example where we use these reciprocal identities. Here we have, use the appropriate reciprocal identities to find the unknown function values. Rationalize the denominator if applicable. And we have the tangent of theta if we know that the cotan of theta is equal to negative square root of 5 over 3. So we want to find tangent of theta. We're given the cotangent of theta, and we know that the tangent is the reciprocal of cotangent. So tan theta equals 1 over cotan theta, which is 1 over, and then we were given the value that cotangent of theta is negative the square root of 5 over 3. So therefore, the tangent of theta will equal negative 3 over the square root of 5. Now we're asked to rationalize the denominator, so we need to multiply both top and bottom by the square root of 5. So our answer is negative 3 square roots of 5 over 5. All right. In the definition of the trigonometric functions, remember that r is the distance from the origin to the point x comma y. So r is a positive value. Now, if the point xy lies in quadrant 1, then of course x and y are both positive values as well. So all 6 trigonometric functions will have positive values in quadrant 1. What about the other quadrants? Here's a graphic that shows the relationship of the trigonometric sine values to the quadrants in which the angle theta's terminal side lies. So we have, of course, as I said, that in quadrant 1, all the functions are positive. Whereas in quadrant 2, we know that x is negative. Y, of course, will be positive. So therefore, any combination that involves x, which is negative, will create values that are negative. Well, the sine, which is y over r, and the cosecant, which is the reciprocal, will be positive in quadrant 2. The other 4 trig functions will be negative. Well, in quadrant 3, both x and y are negative, which means anything that involves x and r or y and r will also be negative. Anything that involves both x and y, a negative and a negative, would then be positive. Hence, tangent and its reciprocal cotangent are positive in the third quadrant. And finally, in quadrant 4, y is negative. So that means cosine and its reciprocal secant, which involve x and r, are the ones which are positive in the fourth quadrant. Using that grid, we can see how the signs of all the trigonometric values are derived. What I want to do next is an example in which we determine the quadrant or quadrants that an angle lies by evaluating the signs with the given conditions. So, identify the quadrant or quadrants for the angle satisfying the given conditions that sine theta is greater than 0 and cosine theta is less than 0. In this case, we know that the sine of theta is positive in quadrants 1 and 2. Cosine of theta is negative in quadrants 2 and 3. Therefore, only quadrant 2 satisfies both conditions. So the angle theta lies in quadrant 2. Now, in our study of trigonometric functions, you have noticed that r is the hypotenuse of a right triangle. And that being the case, neither x nor y could be larger than r. Given those ratios for sine theta, for example, which is y over r, we can determine the range for the function, in this case, sine theta. To do that, I want to draw a triangle with x, y, and r. So let me do that. We have a general triangle. This is my y, this is x, this is r, and this is theta. And if I deal with sine theta to start, that's y over r. And let's look at this. If theta is a very small angle, so something like this, we'll see that we have a ratio of y over r. It'll be positive, and it will be some fraction, a small fraction. But what happens as we let the terminal side of this angle theta come up like here? And this would be my angle theta. Well, what you'll see is the value of y, which is this side, compared to the value of r, what's happening is the value of y is getting closer and closer to the value of r. And in fact, when we get to an angle of 90 degrees, although we can't draw a triangle, you can at least imagine for the moment that the value of y actually equals r. And that's what happens. So again, we won't get a triangle there, but the ratio will be 1. And what you'll notice is, if I then create an angle with its terminal side in quadrant 2, here's r, here's my y value, you can see that what's happening again is that the ratio of y to r is getting less than 1. What I'm saying then is that the sine of theta is never bigger than the value of 1. And if you can take that same idea but bring it into quadrants 3 and 4, what you'll realize is that the sine of theta will never be less than -1. So all of the values, the range for the sine of theta, are between -1 and +1. Which is to say, for example, there is no such value of the angle theta so that you say sine theta is equal to 3. That just can't be because it's not in the range. Similarly, you can't have sine theta equals -2 because that would be out of the range. Okay, well, what about cosine theta? Well, cosine theta is equal to x over r. So this time we would be comparing the x value to r. Well, again, by the same reasoning that we did with y, we should realize that when we have an angle of 0 degrees, that would be where x actually equals r. In other words, the ratio